Hello and welcome to Algebra, as you guys know, the most important topic on the course by a good bit. We've done our introduction stuff. I hope you've gone off and you've looked at your Algebra 101, spent a little bit of time on that. That will make everything way easier. If you could, I'd suggest straight away, right now, pausing the video and just testing yourself in that Algebra 101 stuff. That starts in your notes there on page 8 and it goes all the way up there to page 15. And what you want is your algebra to be a certain level that you're kind of feeling I'm comfortable enough with this. Maybe you're getting around 80% on that. Any lower, you got to go back and work further on that algebra, or the rest of the course is going to be a slog. We're starting off with algebra because it is the most important. It filters into absolutely everything else. But exam algebra is probably just a short question on paper 1. There are, as we look at it in the academy, a few different styles of questions. We like to break it down into being as organised as we actually possibly can. We've got, in algebra, we've got something called a cubic. We've got simultaneous equations, which you would have definitely heard of before. We've got something called inequalities. And then we've got something called miscellaneous. And miscellaneous is just kind of all the other little bits and bobs of algebra that could potentially form a question. What we are looking at here specifically is something called completing the square, and we will look at that in a second. After completing the square, we have to be able to deal with fractions. That's very important. And then we've got another type of question called the nature of the roots. Now, if we cover these bases, we're in a really strong position, not only for this chapter itself, but for other parts of the course. Before we get into it, though, I still got to maybe drip feed or plant a few seeds of algebra that will help us as we go through. So you could do this on one of the pages here, one of the notes pages at the back. You could do it on just a random piece of paper, but there's a few really important things that I believe you guys should know. If I first of all start by just making up this quadratic. Here is a quadratic here, 1, which most of you guys would be familiar with. You probably have seen it tons of times before. You'd be able to do tons of stuff with it, but I want to point a few things out to you. When you were in first or second year, you would have had a question where it said to solve this quadratic. And everybody would have a slightly different way of solving quadratics. You guys might have been given a different way than this for your teacher. As long as you're able to solve it, I don't mind. Maybe you even use the minus b formula for something like this. That's okay as well, but I want to point out some vocab. When we go to solve this here, what we are going to be doing is, when it says solve, we're going to be finding the value of the letter or letters that are in the question. That's what solve always means. And we'll see that very frequently. In this question here, there's one letter, it's x. And because the highest power of that x is a 2, we know we are most likely looking for 2 answers for x. If that was a 3, we'd be looking for 3 answers. If it was 1 answer, and so on. When we are solving, if we are not using the minus b formula, what most people do is some version of factorising. And the way that I was taught to do this in school was we're going to put an x at the front of the bracket, or if that was y squared and y, there'd be a y at the front of the bracket. And then we're going to look at the signs. We're going to look at the signs here. If that's a plus, it means that both of these signs are going to be the same. So if that's a plus and that's a plus, that's telling me that's a plus and that's a plus. If that's a plus and that's a minus, these are both minuses here. If the second sign is actually a negative, both of these are going to be different. One will be a plus and a minus, and it doesn't matter what order. We're then going to look for numbers that multiply together to get 6, that add together to give me 5. More on that in a couple of minutes. We're looking for factors of 6 that add together to give me 5, but we have to take into account these signs here. So 6 and 1 wouldn't work because plus 6 plus 1, that doesn't give me 5. But 2 and 3 definitely works. Now, what we have in these brackets here, and this is really important vocab, so even if this stuff is easy, just take it down, because it might be one word that changes the question, that changes your grade. So I want you to put down that they are called factors. And what factors are things that divide in with no remainder. So if you did, and we'll do long division later on, if we divided this into this, we would get this with no remainder. Similarly, if we divided x plus 3 into that, we'd get x plus 2 with no remainder. If you multiply factors together, you'll get the original thing. And if you just bring yourself back to primary school, where let's just say you were dividing 3 into the number 12. So you're dividing 3 into the number 12. That goes 4 times with no remainder. And that means that 3 is a factor of 12. It also means that 4 is a factor of 12. If you multiply those two together, 12. Perfect. So exactly the same in algebra. If you divided 3 into 13, well, that would go 4 times, but there would be a remainder of 1. So 3 and 4, they are not factors of 13. The reason this is important in the Leaving Cert is the factor is a word that the examiner uses a lot. If you put factors equal to 0, you get what are called roots. So when you use the minus b formula, or when you solve a quadratic, you find what's called roots. A lot of people skip this line, this next one here, and if you wanted to skip this line, that's okay. But just know that it exists because there might be more complicated ones than this in the future. If you put the factor equal to 0, it gives you a nice linear equation in which, if you solve for x, that will give you your roots. Now, you don't have to do the line in blue. Feel free to just stay with the line in black. That's okay, but just that's where it comes from. So again, we've got 2 answers. They are called roots, and we said that from the very start. 2 different answers for x. What do these roots do? Well, first of all, you can prove something is a root if it satisfies the equation. So imagine the question had said, investigate if, check out, investigate if minus 2 is a root of this equation up here. If it is a root, it will satisfy the equation. Those are the only 2 numbers in the entire world that will satisfy this equation here. So to give you an example, if I put minus 2 in for x, I have minus 2 squared plus 5 times minus 2 plus 6 equals to 0. Minus 2 squared is positive 4. We've got negative 10. We've got plus 6 equals to 0. That gives me 0 equals to 0, and that actually proves that that is a root because it satisfies. If you did the same with minus 3, that would also get you 0 equals to 0. If you did that with plus 2, it wouldn't work. If you put plus 2 in here, you would end up with what? Like you'd have actual 4, actual 10, so that would be 14, you'd have 20. So 20 is not equal to 0, therefore it's not a root. The other thing that the root is the root tells us where the quadratic crosses the x-axis. Most of us are probably familiar with the fact that quadratics can either be a smiley face or a sad face, and that's probably okay at junior cert, but at Leaving Cert you can't rely on that because in a few minutes time we're going to be talking about cubics, and you can't actually be talking about faces that look like that. So what we do is we ask ourselves, where does the graph terminate? What happens on the very right hand side? If it's going uphill, it's positive, so you could probably see that that will be a positive cubic. If it is going downhill, it will be negative. You could probably see that will be a negative cubic there. This quadratic is quite clearly a positive because we've got a positive x squared. So if I was to sketch it, I know it's going to be a U shape. But what we've also found is if that's the y-axis and that's the x-axis, we've found out where it crosses it. Minus 3 and let's say minus 2. I know that's not the best number line in the world, but we are able to give that a little sketch there. So far we've got factors and roots. We've got the idea of what solving is. We've got how to show something as a root, that it satisfies the equation. We haven't actually delved into the Leaving Cert stuff yet, but we've started to work on some graphs because all of this is going to actually tie together in the future. So for now, what I'd like you to do is we're going to actually get into the notes now. You've looked at the Algebra 101 recap. If you haven't, please go ahead and do that. But we're on page 16 of our notes. And page 16 of our notes is actually going backwards. It's teaching us to get the root and form the quadratic. What I would like you to do on the top of that page is, I would like you to write, note, complex numbers. Now you know we haven't done complex numbers yet, but it's pretty important you know this formula also for complex numbers. It says on page 16, if you have the root of a quadratic equation, you can create it using this following rule. And this is not in the formula and tables book, so we need to know this. We've got x squared minus the sum of the roots times x plus the product of the roots, and that equals to 0. So x squared minus the sum, x plus the product. So if we take our example from a minute ago, the example that we had on the board was we had a quadratic which looked like this, x squared plus 5x plus 6 equals to 0, and we found out that these were the roots. If I was to use this formula over here, which I would recommend using, it's very, very quick, especially as well if these become letters or something a bit more complicated, or imaginary numbers maybe in the future. If we were to use this here, we could get the quadratic in basically one go. The sum of the roots is where you add them together, so minus 2 and minus 3 is minus 5. So we have x squared minus 5x plus the product. So minus 2 multiplied by minus 3 will be 6. And then if we say minus by minus is a plus, we've got our quadratic already. And that's pretty handy. There is another way of going about it. If we actually just work backwards, so if we just work backwards to what we've done over there, we have roots, and from those roots, we can actually get factors. By just bringing that across the equal sign, that will give me a factor. We've got x plus 2, and we've got x plus 3. There are factors. If we multiply, as we said a few minutes ago, our factors together, we've got x squared plus 3x plus 2x plus 6. If we add the like terms, that is another way of getting our quadratic at the end. For the moment, I would suggest doing this way. I recommend now that you pause the video, and I'd ask you to do question 2.2 and question 2.3. So question 2.2 and 2.3. Pause the video, set a timer for 5 minutes, give it a crack. I'm going to do question 2.3 because it's a little bit different to what we have there. You guys obviously have the solutions to have a look at. Pick one way or the other. I want you to write where it says 2.3. I want you to write above that, when we have letters, think, what would we do if there were numbers? Now, the idea behind that is over the last 5 years, where we usually have numbers, the examiner has started to put letters. And students absolutely hate that. It just makes it look more complicated. If you just ask yourself in general, what would I do if it was a number, and just treat the letters as a number, it makes life way easier. I don't think this one is hard, by the way, but it's a general theme we're going to go with. It says, form the quadratic equation with the roots x equals to a and x equals to b. So x equals to a, x equals to b. Cool. If I use this formula here to sort it out, I have x squared minus the sum of the roots. So adding those roots together is just a plus b. I can't get any simpler than that. That's what it has to stay with. X. And then it says plus the product of the roots. So plus a multiplied by b will be plus ab equals to 0. Something that I really would like to point out to you is in algebra, I always would like you to, and write this in red pen, any of the stuff I write in red pen, please you do it as well. I really need you to put this stuff in alphabetical order. I need you to put algebra in alphabetical order. It's not that big of a deal here. If you wrote BA, it's not wrong. But down the road, it allows you to see more like terms. The only exception would be if we've got like an X or a Y in a question. They always just go at the end. So, to sum this up, before we get into our first actual Leaving Cert style of question, we have dealt with the following. We've said that we know what solving means, we know how to do it. We know what factors are, we know how to use them, and That's going to be a big thing for cubics in a few minutes' time. We've got roots. I think that's very, very important for us. We've got our new formula that's up there. That's brilliant. And the last thing that we spoke about was we spoke about the graph itself, how the graph can actually be represented, and this is going to be really important throughout our journey together. Okay. The first Leaving Cert question we're going to do is something called completing the square. There is, as you guys know from our introductory video, there is at the end of this section a code for Quadratics that gives you all my best algebra questions, all the best ones. A really good question for this next section is the 2017 question 1. It's a 25 marker, and it actually includes the completing the square, the nature of the roots, and it allows us also to explore using the minus b formula a little bit and when to do it. If the examiner says solve, we're pretty okay with this. Like I'd say some people kind of thought the last 15 minutes were a bit too easy. Or maybe you could use the minus b formula on this if you had to, but pretty much everyone would be okay with it. There are certain times in the Leaving Cert, though, that people just go off track because they don't know what the examiner is asking them. If on page 19 you look at the example and all you saw from that was x squared plus 8x plus 10. If that's all you saw and you went and you solved that and you used the minus b formula, you wouldn't be right. You would actually be wrong. You get 0 marks. If you look at this question here, example 1 says, write this quadratic in this form. X plus a to be squared plus b. That's what it says there. X plus a to be squared plus b. That there is saying, how you mate, complete the square. That's literally what it's saying. It's not saying solve it, it's saying complete the square. There's 2 reasons we would complete the square. Most important reason is the examiner asks us to, and the second reason is to find what's called the minimum point. Okay, so if we figure out actually how to complete the square first, I'll then talk about the minimum point after. In our notes, as you'll see there at the top of page 19, we always have the English. We always write it out in normal people language first, and then we give an example to show you how we can work through it there. I'm going to do example 1, but maybe look at me instead of looking at the notes there, and just see, do you understand every bit that we're doing here? So, step 1, write down the first 2 terms of the quadratics exactly as they are. Okay, so we've got x squared plus 8x, step 1, done. Step 2, half the number in front of the x, square it, and write this down next. So there's the number in front of the x, also called the coefficient, which is an important term. So half that number, which will give me 4, square it, and then we add it on. Step 3, subtract the number you just wrote down. Cool? And step 4, write down the final number from the original quadratic last. Now, it might not look it, but that there is the exact same value as that. If you took your age and you add 3 and then subtract 3, it'd be weird, but it's still the same age. The reason we do that here is because once you do that, this is definitely going to be what's called a perfect square. So you can see we want our answer as a bracket squared, i.e. the perfect square, plus b, which is just plus another number. Every single quadratic in the world can be written as a perfect square plus another number. If you write down the first 2, half the number in front of x, square it, add it on, take it away, write down the last term, I guarantee you that these first 3 will form a perfect square. And what I mean by that is, if we just factorise it like we did a few minutes ago, so we've got x and x, we've got plus and plus, 4 and 4, they are going to be the same. Those brackets will be the same, which allow you to write it as a perfect square. Anything by itself is that thing squared. X by x is x squared. The bracket by the bracket is the bracket squared. You can then put this into your calculator, because sometimes the numbers are a bit dodgier than that, and that is you completing the square. That is still the same value as that, but we've written it in the form the examiner wants. Sometimes people get a little bit upset if their pluses and minuses don't match the pluses and minuses here. I wouldn't worry about that. Later on in the year we'll talk about, see the way it says A and B is an element of Z, and we've got Q and we've got OR, so that actually lets us away with it. But the fact that the overall thing matches this is what we're after. We have completed the square. Why? Because the examiner asked us to. Perfect. Now we'll give another one of those a go now in a second. But I want to show you something. See this step here? See this step where I factorise it? Most of my students would actually skip that step. We wouldn't do that. We just go straight from here to down here. Because in the future we're going to have decimals, we're going to have hard numbers that aren't as easy to factorise. If we know that it's always going to be x and then something squared on the outside, the only thing we don't know is this number here, we can actually, as I said, skip this middle part. We have a little bit of a hack. Half the x coefficient will always be the number that's in here. That's plus 8, so that will be plus 4. If that was minus 8, that would be minus 4. If that was plus 100, that would be plus 50, and so on. And then we can just use our calculator for that. That becomes really, really, really useful. That's skip. So again, it's just half the x coefficient goes in there. X, that will always be x, and that will always be squared. And that becomes really useful if we've got decimals and stuff involved. Cool. So that's if they ask to do it. Now, a few minutes ago, we spoke about, let's just pretend I don't actually know what the roots to this equation are. We spoke about that the root is where it crosses the x-axis. Brilliant. Some of you guys might have done some calculus before, and you would know if you see the phrase maximum or minimum, basically as a reflex action, you think differentiate, put equal to 0. That's what you think. But that's not always actually feasible. We can't always do that, because in like the 2017 question, it asks you to complete the square, hence find the minimum point. Hence means you've got to use the thing you just did beforehand. You have to use the thing you did beforehand. Hence or otherwise means use the thing you did beforehand, but if you're really stuck, you can make it up. But in 2017 it said hence. So we got into something like that, hence find the minimum point. The minimum point is exactly what it says. It's the point that's the minimum on the graph, where it was going downhill and now it's started to go uphill. From the completed square, we can actually get that very, very, very simply, very easily. All we have to do is change the sign of the number that's inside the bracket, so that plus 4 became minus 4. If that was minus 11, it would become plus 11, and keep the outside number the same. So change the number change the sign that's inside the bracket, keep the outside one the same. That is the minimum point. Now, I know they didn't ask it for that in the example. You should probably just write that in. Explain to yourself what that is. In a few weeks, you might forget exactly what it is. But there's our minimum point. Again, I don't actually know where the y-axis here, so I don't know if it's on the right or the left, but they haven't asked us to sketch it. We just wanted to know what the minimum point was. You can, in your own time now, you can try question 3.1 and question 3.2, and then I'm going to show you question 3.3, the one difference and the one idea that's quite like the 2017 exam question.